Slide this out of the way, and let's get started. So I'm going to go over section 1.6 for you. We're going to talk about some basic graphs, what they look like. What we're looking to get out of this is the shape of basic graphs, not necessarily exactly, kind of understanding what different things will look like. And then later we're going to talk about transformations and what we can do to modify those graphs to fit a particular model. Okay, so that's where we're going. So let me get started here. We want to recognize basic functions, and the one that we've worked on up to this point is linear function. Okay, so we've got the basic limit, the linear function. This kind of fits everything. We're not really going to do a transformation on this stuff. This is kind of like a built-in transformation, and we can move everything around, and you kind of understand this. So we talked about the slope m. The slope n kind of gives us how fast this is going to rise, right? So a larger slope would get us faster slope. If this is negative, it goes down. The constant function, it doesn't depend on the x and the slope. The slope is 0. The slope is 0 along here, so that's the constant function. Here it would just be y is equal to 2, or f of x is equal to 2. Give me any x, whatever the x is, the value is 2. Here is what I consider to be the basic function for this, and that is just y is equal to x. So whatever the x is, the y is the very same thing. So 1, 1, 2, 2, 3, 3, negative 1, negative 1. That's kind of the basic function as far as the linear. And then later on, we're going to talk about transformations. The easiest way to think of this is going through this transformation. The b is just going to shift it up and down, and then the m is going to increase the rate at which we go up. So that's pretty straightforward with that one, okay? So here is the ones that we're going to really use, and this one is listed as f of x is equal to x squared, but any time that you have an even power, so this is x squared, x to the fourth, so it wouldn't be a quadratic, but so the quadratic is the power is equal to 2. But anytime you have a power function with x4, x to the 6, an even power, it's going to look like this. The only thing is that this is just going to go up faster. So it's going to be an increased rate, but it's still going to be that basic shape, and that basic shape is called a parabola. So here's a cube function. The cube function is x is equal to 3, but this is exactly the shape that you should think about when you have any odd power. So x to the n is equal to 3, x to the 5th, x to the 7th. When this power is odd, you're going to have this shape because you can do negative. So if this was a negative, and I multiply negative times negative times negative, I'll get my negative numbers. So this is just this shape where this is just turned down, okay? And the basic that I want to get out of here is anytime I have an even, I'm going up, up, and here the odd is going to go down, up. And I'm going to refer to this thing as like up, up, down, up, okay? The square root function, this is the very same shape as anytime I've got this index being an even number. So this could be 2, 4, 6, 8. The square root is an understood 2 here. Okay, I can only take a square root of positive numbers, so I can only, this has to be bigger than or equal to 0. We've looked at that natural domain, so we just take the square root. So if this was 0, 0, if this was 4, the square root of 4 would be 2. So out here at 4, I'm finally getting up here at 2. The next one I would pick up that I would know how to do is 9. The square root of 9 is 3. So out here, once I finally get up to 3. But the important thing to remember about this is anytime I'm taking an even root, I can only do the positive version. If I do a cube root, this is the cube root function. However, if this is going to be the very same thing as this was 3, 5, 7, 9. It's not going to be called the cube root, but it'll be the nth root in odd. It's going to look like this because I can take an odd root of a negative number. So if this was negative 8, the cubed root of negative 8 would be negative 2. So out here at negative 8, I would be down here at negative 2. So again, the basic shapes, we're going to refer to those when we do like quick graphs of other things. We're going to say, okay, I know what the basic shape is, and then I'm just going to shift this over. This is going to be shifted to the right, shifted to the left. Here would be maybe to the right. I can shift this to the left, but I've got to modify what's under there, okay? The absolute value function, this is just the absolute value. So for the positives, if this was 1, that would be 1, 2, 2, the absolute value of 2. And on this side, if this is -1, the absolute value of -1, that would be the +1, and over here. So this is basically that y is equal to x, and this would be the y is equal to the -x over on that side. Okay. So the reciprocal function, this is another one that we just have to kind of understand what's going on. So I'm going to kind of look over here. I want to move this over to the side just a little bit and make some comments about that. So y is equal to 1 over x, okay? We've talked about we can't divide by 0, number 1. Can't divide by 0, right? So 1 over 1 divided by 0 is undefined. I don't know any number that if I had 1 over 0 is equal to any number, and if I did my check from arithmetic days, I'd say, okay, if this was that number, 0 times n would be equal to 1, but I don't know any number that when multiplied by 0, this should be 0, okay? So I can't do this. So over on the side, I know I can't do this, but what happens as x goes through different things, okay? So it's easy to see as x gets large. So if x goes to infinity, and I'm saying like x is going through, let's go to the right side, like 1 to 100, 1,000, okay? Y would look like, 1 over 1, which is 1, 1/2, 1 100th, 1 1,000th. So this thing is going down, okay? So over on this side, as long as I'm going out bigger, this is going to get smaller, 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 okay? So this part of the graph, I want to start from the 1, and this is going to go here, okay? That's easy. How about if I do x is equal to -1, I'm going to start at that one again, -100, -1,000, and then my y is just going to be -1 over -1, which is -1, 1 over -100, 1 over -1,000. Okay, so this is getting smaller, but it's a negative number. So I'm going to start right here. This would be my -1, -1, and then that would be getting smaller, but they're still negative. As long as x is negative, that's going to be. So this is picking it up from here. But what's happening between here and here? And that's where I want to kind of start explaining it a little better, okay? I'm going to build a plot of that one. Here's my x's, and here's my y is equal to 1 over x, okay? I'm going to build smaller and smaller numbers from 1 down to 0, okay? And what I'm thinking of is I'm going to let x be like 1 over n, and then I'm just going to say, okay, well, that's 100, 1,000, 10,000. So what would these numbers look like? Well, let's go 1/10, 1 100th, 1 1,000th. So these are smaller numbers, right? Smaller numbers, and I'm just going down here. What does this look like when I'm here? This one is just 1 over 1, which is 1. That one we've already taken care of. What about if I do this? So my y is 1 divided by 1/10. So what do we get there? I've got a fraction divided by a fraction, so I want to do the invert and multiply. This is the same thing as 1 times 10. I go to 10. So if I back up, so this is 1/10 right there, probably 1/10. This thing is up at 10. What about it at 1/100th? 1/100th is closer here. It's almost at the y-axis, but still away. Then I would get 1 over 1/100th. Invert and multiply. This thing is up to 100. So I'm getting closer, and now I went from the 10th up to 100 when I'm going to the left. This is getting closer and closer to 0, from 1 down to 0. The 1/1000ths, 1 over 1/1000ths, this would be 1 times 1,000, and that's 1,000, okay? So from that point, the closer I get, and if I represent my fractions like this and do it invert and multiply, this thing is going and just blowing up, okay? This, as x goes to 0, as x, I've got a little guy here, and he's walking to 0, the y value blows up, goes to plus infinity, okay? What about the other side? We start here, and I'm going to do the very same thing, except now these are just negative numbers. So if I just started back over here, and if I go my x, and I'm going to start -1, -1/10, -1/100th, -1/1000th. You know, down here somewhere is there. If I keep doing this thing, this would be my -1. That would be a -10. I do the invert and multiply here again, -100, -1000. And that's this going from here, going this way, and this thing starting to blow up that side, okay? And here we know, and that's that graph. This concept of when the denominator starts getting close to 0, as denominator goes to 0, the y is going to either blow up in the plus direction or the minus direction. Here, as x went to, so this was from the positive side, here's a little notation, and then here is going from 0 from the negative side, y goes to -infinity. Okay. That's the basic of this. Now we're going to move these things around and do different things with that to kind of work on it as we go. Okay, so that kind of takes us off for some basic functions. We're going to be seeing these things back and forth, and later on we're going to use this ideas of these basic functions and what their graph looks like to sketch more complicated functions, but we're going to use that idea of this is the shape, and then I'm going to move it over. So I'm not going to do XY graphs. I'm not going to do these XY tables to come up with numbers. I'm going to say, okay, I know what the basic shape looks like, and then depending on some other things, I'm going to move these things left, right, up, down is what it's going to look like, okay? So that's the kind of the concept of transformations as we go, okay? So we're going to start out with this concept of vertical and horizontal translations, and these are just shifts. So these are transformations under these things, these global things, verticals and horizontal translations or transformations. And then under that transformation, is it a vertical or is it a horizontal? Okay. So consider a function, y is equal to f of x. And we've done this many different ways when we've considered functions. This could be a set of ordered pairs. This could be a graph. I just show you the graph. There's a graph, and that's a function. Or I could give you the rule, the 1 over x, x squared, those are by rules, okay? But it doesn't matter, okay? And I'm going to show you different ways we're going to look at this thing. Let C and H represent positive real numbers, okay? So these are just positive, so it kind of keeps it going, you know, in a manner that you would expect. If I know what the graph of y is equal to f of x is, if I just add some number, so this is like +2, all I'm going to do is just go up 2 units. I'm going to take that basic graph, right? I'm going to take that basic graph and then move it up that many units. So if this was a point on the graph, if I've just given a picture, and if I just say, what would that look like if I did +3, I would take the XY and move that Y up by 3. The X would be the same place, I would just move it up. Okay, again, this is positive, but you're just kind of considering I'm subtracting off that number. This would move it downward. So if I had Y is equal to f of x minus 3, where it was a particular number, the Y value I would subtract. Okay, so if I went here, let me kind of grab some stuff here. One. Let me go grab from here. This is the best way to do it. Let me get Desmos rolling. So I'm going to use the C, and I'm going to do a basic, one of our basic graphs. Let's start out with the quadratic. Y is equal to x, my shift, x squared. There's the basic graph of y is equal to x squared. And then I'm going to consider, here's my C. And it's going to ask me, do you want to add this slider? I'm going to go, yeah. So here, this would be x squared plus 1. But I like this because I can move this thing down. That would be the 0. So this is basically just y is equal to x squared plus 0, or y is equal to x squared. That's our basic graph function. And what would it look like if I just added numbers to it? If I'd added 1, I didn't move it left and right. I just moved it straight up. Here I moved it up 1.5. If I want to move this thing up so this point is at 5, it would just be x squared plus 5. So now this is x squared plus 5. If I wanted to move it down, let's go down to put it to the -5. I would just go x squared like that. So I made this be -5. So this is x squared minus 5. So that constant is just moving it exactly up or down. If I know what the graph of some function is, and it doesn't have to be that, then this plus or minus C just does. So here, I'm going to go back to here, backspace, backspace, backspace. I'm going to go to my little symbols, and hopefully I can find my square root. And if I do the x and make C is equal to 0, there's my basic function of y is equal to square root of x. And then if I just add numbers to the plus z, that's outside of the radical, that just moves it straight up or straight down, okay? So this would be y is equal to the square root of 3, I'm sorry, the square root of x minus 3.3. So at x is equal to 0, square root of x would be 0, and then this would just be the negative 3.3, the y-intercept, okay? So that's the basic vertical shift. A horizontal shift. This is a little different. This is a little harder to do and harder to understand. Okay, and you'll get this kind of mixed up back and forth. The graph of y, so I know some function, f of x. If I apply this transformation x minus h, it's going to shift that graph to the right by h units. Okay, so if you knew what, we know what this looks like. The y is equal to x squared, right? That's that. And I just draw a quick picture, quick sketch. It looks something like that for my basic graphs. If I see something that looks like this. So this is f of x is equal to x squared, and I want to generate f of x minus 3. Everywhere I saw my x, I replaced it by x minus 3. This is this graph, shifts graph right. This is a positive number. There's the negative. It actually shifts it right and by 3. Okay. So where this was at 0, that was 0. Now it moves it over here at 3. 1, 2, 3. This point is now my vertex. I know where one point is. That's there. This shifts it over. So this is going to go here and here. Okay. Plus h goes to the left. So I'm going to go back over here to Desmos. I'm going to kill, let's even start out with this one. So I'm going to get rid of my slider here, and I'm going to get back up under there and go minus h. Add my slider, yep. I want to make h equal to 0. There's our starting, here's our basic graph of the square root of x. Now, if I go to the right, so this is moving at 3, 1, 2, there's the 1, 2, there's 3. So right there is the 3, 0. So h is 3, 3 minus 3 is 0 is where we start, because this has always got to start at the positive value. Now, this was the cubed root. This would continue down here, and it would just go up. What happens if it goes positive? So this is a negative, negative, which would make it positive. X minus a minus 1 would be the x plus 1. That's shifting it to the left. So I can move that anywhere along by doing a basic transformation of just the x minus h. Okay, so if I would do this thing, I could kind of say, this is what I would like to do. I would start off, I want to graph this function. Well, I know how to do this absolute value, and then this would just be, I'm sorry, the square root of x. This would be the square root of x just up by 2. Okay. So here, if I did this, here is my base function. I know 0, 0, 1, 1, 2 square root of 2, 3 square root of 3, 4, 2. The base function. And then if I wanted to graph this, the x's are going to be the same, but my y, this is the g of x, is just whatever this value is up by 2. 0 is 2. So 0, 2 I plot. 1, 1 instead of 1, 1, it would be 1, 3 because I've moved it up by 2. Okay, and here's these, the square root of 2 is approximately 1.414, and then I've added 2. Okay, and here's the 2, and now I moved up by 2. Here is the different, here's f of x. My x is going to be over, and this is going to be, so what it was 0, it's going to be at negative 2. So I'm moving the x over by negative 2. So this one's a little harder to see, and the way they've done this is not like a really good version of it. Okay. Okay, so they said here's 0. Now where this thing is 0 plus 2. So if you're looking, here's the 3. That's, so for 0, it's the same thing as where I'm over. Okay, but it kind of, the way they did this is not a very good version of plotting this thing. You want to say here, this is where we're going to do. This shifts it the left 2. So instead of being at 0, we're at negative 2, where the y would be 0. Negative 2 plus 2 would be 0. The square root would be the 0. Okay, if I shift 1 over by 2 for this family, this would be 1 minus 2 over. This would be negative 1. Negative 1 plus 2 would be 1. That would be that, but the x would be the negative 1. Here would be the 0. 0 plus 2 is the square root of 2. So 0 would be my x because I shifted it, and then that would be the value. So here I'm only tweaking the x numbers, subtracting 2, moving to the x number to the left, and then I keep my y. Here I keep my x's, and then just add 2 to the y's. Okay. So this one, I wouldn't do it kind of what they did. I would just take these values and just shift the x values because that's what I'm going to do. Okay, here's the up. I would take the y value, move them up by 2. Here I would take the x values and move them over 2. This goes to here. This one goes there. This one goes, I'm sorry. So the next one would be this. This goes to right there. They do a better version of it here, but it still is not kind of clear what they're doing. They're just saying for a given y, move this over 2 to give me the transformation. So if I know this is the one that I know. If I know this point, I'm moving it over to get my new one. Okay. And here's the obvious one as your starting point. What's the difference between here? Again, I'm moving down. So my parent function or my base function is y is equal to x squared. These I'm just picking up. Okay. And then if I'm doing, oh, they switched it. This is supposed to be x squared minus 2. This is supposed to be x squared minus 2. So they're shifting the y down -2. Okay. 0 minus 2, 1 minus 2, 4 minus 2 to give you this version. And again, that should be x squared minus 2. Okay. And here is to the right. I'm going to keep the y value. And then I would actually shift the x value over right. So this would be 2, 0. Well, I would plot 2, 0, 3, 1, 2 and 2, 4, 4, 5, 9, 6, 16. Instead of trying to do it this way. Okay, instead of trying to do the numbers and do it. This is kind of like a basic plot for 0 that goes to 4. I would start with these points and say I'm shifting this thing over. So I'm modifying the x's by doing subtracting or adding 2. I'm moving it to the right. Where it was 0, 0, it is now, when this is 2, it's going to be 0. 2 minus 2 is my new 0 point. Okay. So here's basically the picture. If I know what y is equal to x squared, when I do the minus 2, I'm pulling it down 2. There's, I'm just plussing and minus. And here I'm shifting it right by 2. So there's the original. The points that I know, I shift right by 2. So the 0, 0, that vertex would go to here. Okay, over by 2, over by 2. Here I know this one, 1, 1, that goes over by 2. Still 1, but the x is now 1 plus 2 is my 3. Okay. So here's some skill practice of just doing these basic ones. Here again, take that square root function. So I kind of picture this thing in my mind without actually doing the graph. This is what I'm doing. I'm saying I know what that parent function is. That's y is equal to the square root of x. And then I'm moving it down because this is outside of here. This is just moving it down. So if this was 1, 2, that's 0. Down here is where I would start. And it would be the very shape. So it would be parallel, not parallel, but the same distance all the way through. And that would be y is equal to the square root of x minus 2. The square root of x plus 3, you see this is under, so I'm modifying the x value before I do the base function. So that's inside. Here would be my base. If I do the square root of x plus 3, I'm moving over 3. I'm starting there and then going up. So this would be y is equal to the square root of x plus 3. I've shifted this point over by 3. Any one of these points would be shifted to get my new one over by 3. It should be, but you know, that's kind of a couple of quick points that I would do. Okay, so here's another one. Graph the function defined by g of x is equal to the absolute value of x plus 2. So I don't have to go off doing a bunch of xy plots. I just have to recognize that is a horizontal. So if this was plus 2 on the outside of that, that would be a up. That would be a vertical shift. Here it's inside the base function. So I would go, I know what the base function is. I have to recognize the base function. That's my base function, the absolute value of x. And then the plus 2 shifts it over by 2. So 1, 2, my new point goes over to there, and then this would go up, and this would be y is equal to the x plus 2. That's the whole idea, that I kind of know the basic shape. I can sketch it. If I need more exactness, I do. But, you know, if I need more exactness, then I go over here and I go, give me my keyboard with the absolute value. This should be in here. No, I've got to do, oh yeah, right there. So there's my absolute value. So here's my x. And then y is equal to, go back down here, grab the absolute value of x again, but I'm going to do x plus 2. And look what this does. You see this point? Moves that point over to there. If I know this point, negative 1, 1, shift that thing over, and that would be that point. Still the height, but it would just be the x modified. Okay. This would go here. Okay. This here, this here. That's which way it's going. Okay. So if I did 5, that was where it would go. I'm just shifting this by 5 to the left. And I can do a quick sketch of that because I pick out some point that I know what it looks like, and then through this transformation, the horizontals, I just move that over. And that's the idea of transformation, is that I can look based on a base function if I get some modifications. Now again, I could move this over. Now how about if I wanted to start it here? Move this over, and then this would be here. That would be the 2, so I would just add plus 2, and that would get me over. Shift left by 5, go up by 2, and then we start to draw. Okay. And let's see, let me go from here. So here's a combination. And again, you have to kind of consider where the transformation lies. So graph the function z of x is equal to x plus 1 squared minus 4. Okay. So what is the base function? You have to look at it and you go, okay, I recognize I've got something squared. That's got to be my base function. Anytime I go this way, so what I've done is applied, so from f of x is equal to x squared. To get this, I've done f of x plus 1, which is x plus 1 squared. That's that horizontal, okay? So I've moved this over to the left by negative 1. That's my first thing. So the piece that I kind of like to think of in quadratics is the vertex. Here's the point I know. This transformation moves that thing over. Whatever point And this is the most fundamental over by 2. Okay, so if I go over here now, when they did this graph, they took this vertex, moved it over to the left by 2, no, by 1, I'm sorry, they're doing by x by 1, sorry, by 1, and then this is the vertical. After I do this, my order of operations, this is the last thing I do, I move it down by 4. Shift left 1, down by 4. Graph the function absolute value of x minus 2 plus 3. Here, my base function is the absolute value. So I picture this. That's what that basically does. And then I'm saying here, I'm applying f of x minus 2. And then this is the horizontal, and then I'm doing f of x minus 2, this, and then I'm doing plus 3, which is a vertical, okay? So right, since I'm negative, I'm going right by 2, 1, 2, that's my new point, and then I'm going up by 3, 1, 2, 3, so that would be where that is, and that's that picture, okay? Use translations to graph the function defined by. Okay, so I have my basic graph. I say, oh, it looks like I've got a radical square root function. That's my base. And then I'm applying this transformation, the x plus h, x plus 2. That's what this looks like, x plus 2. Okay. Let me get this over. Okay, so that's the x plus 2. This shifts left, shift left by 2. Not times 2, I should just say. It shouldn't have. That's by 2, but, you know, shift left 2. How's that one? And then when I do this, this is what I'm doing here. Plus, take the basic function, do the shifting of x plus 2, and then do minus 5. So down 5, okay? So I would think, I've got this picture in my mind. Here's my 0, 0. Shift left by 2. So over here is my starting point. And then down 5, I would just count 1, 2, 3, 4, 5. Somewhere right there is where I would start doing my picture like that to get a basic starting graph, okay? So when x is negative 2, f of negative 2, what does that look like? That's just negative 2 plus 2 minus 5. This is 0. So it's equal to negative 5, and that's what that is, negative 2, negative 5. Okay. The shrinking and stretching, the vertical shrinking and stretching is easy to understand. To me, it's easy to understand. The horizontal, it takes a little, you know, it takes some visualization and to work it. And I just kind of group it through. Here's this, the scaling. So I apply vertical and horizontal. I don't worry about this shrinking and stretching because it's going to depend on whether you're talking about shrinking or stretching in the y direction or shrinking and stretching in the x direction. I just say it scales. Okay, and you'll kind of get that idea in just a second. Okay. So basically, I'm going to start out with some function like we did a while ago, but now I'm going to do the multiply. You remember where I added out here past this? I'm just shifting up and down. Now I'm going to, whatever that y value was on that function, I'm multiplying it times a. And if a is just bigger than 1, so this is 2, 3, I'm really stretching it vertically by that factor. I'm scaling it, so I'm getting there faster. And here, if it's less than 1, I'm really dividing, right? So I'm multiplying it, but it's a percentage of this thing. So I'm really shrinking, so it's not going shrunk vertically. That's why I don't like these things. It just scales them, okay? I've got to, if you look at me, I stretch vertically so it's going faster, or shrink vertically so I'm opening it up. Okay, it's what they're talking about. But I just consider all of these things, I scale by whatever this number is. Okay, so I will show you. Let's kind of go back over to Desmos. If I grab Desmos here, let's go with this one. So we have a base function, and now on the outside, I'm going to do some a times this function like that. Add the slider, yeah. Here's my a is equal to 1, so that's my base. But now if I make this a larger number, this is like the slope now. This is going to make this up faster. That's the very same thing. See how I go? This is bigger. This is now 3.6 times the absolute value of x. So anytime I see something, a bigger number on this thing, I think I'm taking the base function, and if this is a larger number, I'm just kind of thinking I'm squeezing this thing in. I'm getting it there faster. So I'm scaling it by 5. So instead of being 1, 1, I'm 1, 5. Or this is 1, 4. So 1, 4. Okay. Because at where it was, this was 1. Absolute value of 1 is 1. This would now be 4 times 1. It would be 4 instead of the 1. Okay. And now if it said between the 0 and 1, now it's a slower slope. So I've actually, pulled this thing out, or I just scaled it again by 0.5. Okay, so one thing while I'm here, if a is negative, it flips it across there. So I consider this, I'm going to add this thing in, we'll see it in the slide in just a minute. I'm going to scale it by 2.5, and then that negative gets flipped. Now, if I did plus 6, I want to do my scaling first, my flip, a scale, flip, and then I add 6. I don't want to do the 6 first. I've got to maintain my order of operations, and I have to think it through. Okay. All right. Here is the one that is harder to see. If I do on the inside of the function a times x, so if I go from, I know what f of x is, right? And let's do the square root of x. F times 2x. This would look like this, okay? So I see this function, I have to recognize that, oh, it's a radical, that's my root, square root function, but now I've done some scaling. What does it make it look to the graph? Here, the bigger this number is, so if you started out with like this, it really kind of messes this up because the x's now are going faster. So this is actually going to make it come up faster, okay? So this one would be here. This would be faster. I'm going through the x's faster, okay? So they say it shrunk horizontally, shrunk. Instead of being stretched out like this, it shrunk horizontal. And then if a is less than 1, so this will be x over 2, then you're going to kind of go out, okay? So let's kind of go back from here. And if I put this on the inside, so this is 2x, you see how that went up faster? 5x, it went out faster because the x's, even though the x's are 1, 2, 3, 4, now you're multiplying them to make your input bigger before you do your output. Here's a good one to see this with. I'd like to show you this. I'm going to do A, and then I'm going to do my functions. I'm going to do this function. We don't cover this in here, but it's easy to see, and I think you've seen this. This is a trigonometric function, so I'm going to go bx. Okay, so I've got a slider A and a slider B. Yep, I want that thing. And I want to see what each one of these do. So here's my A. This is like the amplitude. So if you've seen some things on like TV music like pure tones look like this. They vibrate up and down, and they continue on. So here is the amplification. So if I turn on the volume, turn up the volume, I make the vibrations higher. Okay, that's what the outside function does. That's the vertical scaling. So I'm going to leave this up there by 5. So normally this basic sine function goes between plus or minus 1. This flips it now, but I want to keep this positive. So let's go up. And then this one's on the inside. This should have been a B. So here's my B. I don't need this thing anymore. So my B, watch what happens here. If I go B bigger, I'm basically bringing that stuff in. I'm going through the X's faster by 8.1. Okay. Here's an odd thing that if I do the negative, it kind of flips that thing around to make the negatives were what would be positive. So it kind of reflects it around that 0 point. Okay. Here's less than 1. Here's the more than 1, and I'm bringing them in. And again, my amplitude is going this way. On the outside, on the inside. Those are the basics. Sometimes it is hard to tell. This is on the outside. So here we're just multiplying the y value. We do the calculation first and then multiply it by 4. So if I've got my base functions here, 0, 0, 1, 1, I do this, I know this plot well. Here the 4 times, I'm just multiplying the y value times 4. 4 times 1, 4 times 4, 4 times 9, 4 times 16. Okay. Here I'm dividing, so it's 0 times 1/4, 1 times 1/4. So those are kind of obvious. Those are the graphs. Again, vertical. Here is the horizontal. And now this is, you kind of have to work backwards to get these things. So we'll need to do this in lab to kind of pick out the points. But so instead of 0, you would be kind of the thing where you would be doing the 5. Okay. So you're going through the X's faster. We can work backwards, but it takes a few minutes to get those things. We just basically set these equal to what we know and work backwards. Okay, to find the X's that correspond. Okay, so some of the key things that you're going to be able to do on ALEKS is, given a graph, I'm going to apply some transformation, and then I want to do the transformation. Okay, so use the graph of f of x to graph y is equal to 4x. Okay, so here's what I know. Okay, so I know, here's the ones that I know, and I want to do this transformation. Okay, and what I'm going to say is, I know, so here's the thing. At -3, when I finally get a value of x equal to -3, I do a -1. Okay, but what is my new thing? Where is this thing going to be equal to -3? So it's really -3/4. So here's how I'm going to do this. I want to know when 4x is equal to -3. Well, that new value is going to be 4. My x is equal to -3/4. okay? So my point at -3/4, when this is -3/4, look what happens. This is equal to my, through that transformation, let me do this. F of 4 times the x, and this is -3/4, that's f of -3, and from the graph, I go back over, what is that? That's the -1. So that point is -3, -1 on the graph, okay? So the -3, -1 goes to -3/4. -1, and this should be, this is not. This should be right there. Not sure what they're doing here. They're just saying this piece is shrunk. Basically, they're just saying, what would it look like? I would shrink it, but they didn't do the mappings. They didn't plot these points like they should have had. -3/4, -1. But they're just saying, here is the shrinking because I'm going through this stuff faster. Okay, but they didn't do the correct starting points, and that's what you needed to do here. Again, I want to know when 4x is equal to -1. This is publisher slide, so I just picked them up. -1, 1. So f of 4x, right? I'm saying I know what the point -1 goes to. Where is my new point when that is equal to -1, when I get -1? Well, that's -1/4. Well, so x is -1/4. I multiply it times 4. I get -1. I know that this goes to, when x is -1/4, that's going to go to 1. This is good up here. They just did kind of a, here's a general of what it does is kind of shrink this thing. Okay. So the reflections across the x and y axis, if I do this, the graph of y is equal to -f of x, so when I throw that negative, that's what I did before. It just flips it around the x-axis. So if it was positive, well, when I do a negative number here, it just goes to a negative. So if I know these points, this is my y is equal to f of x of points, right? So if it was 1, 2, and I want to know what happens when I do this transformation of y is equal to -x, that would go for here. 1 goes to 2, that would be the 2, x is 1, this would be the 2, this would now go to -2. So it flips positive to negatives. Negative, if I started with 1, -2 as my y is equal to f of x, when I did the y is equal to -f of x, that would just go flip that over, okay? And this is the very same thing. And I did this kind of a while ago when I said, look at this thing flipping around here. The graph of y is equal to f of -x is the graph of y equals f of x reflected across the y-axis. Okay, so here, I'm going to do this real quick. So I'm going to kill these, do one we know and love. Y is equal to x. Now let me do something different. Y is equal to square root of x, because we'll see this better. Okay. So if I do this, and if I put a negative in front of that, that just flips it around the x-axis. -2, that would just be faster. -1, the positive version. Now if I do it here, look what happens there. I flip it around this way. Okay, so if I did -2x, sharper, -5x, I'm bringing this, squeezing this thing in. but I'm flipping it around the x equal to 0, the y-axis flipped across here. So this again was positive. That's what that would look like. Negative flips it around the y-axis. Okay, so I'm going to kind of pause right there. I think that's good for this time, and